morning, students. Today we will start a new unit, that is Unit 2, Soil Water Plant Relationship and Water Requirement of Crops. First topic is Soil Water Classifications and Soil Moisture Characteristics. Soil Water Plant Relationship. Soil water classifications. When water is added to dry soil either by rain or irrigation, it is distributed around the soil particles where it is held by adhesion and cohesive forces. It places air in the pore spaces and eventually fills the pores. When all the pores are filled, soil is said to be saturated and it is at its maximum retentive capacity. There are mainly four types of soil water: structural water, gravitational water, hygroscopic water, and capillary water. Structural water or molecular bounded water, it cannot be removed by oven drying. Gravitational water, the water in the soil due to the movement of water under gravitational forces. It moves into, through, and out of soil due to gravity. Hygroscopic water, water which is absorbed from the atmosphere and which is held tightly by the soil particles and which is unavailable for plants to absorb, is called hygroscopic water. It is the water lost from an air-dry soil when it is heated to 105 degrees Celsius. Capillary water, water that is retained in the soil along with hygroscopic moisture and water vapor after the gravitational water has drained off. Capillary water is held by surface tension as a film of moisture on the surface of soil particles and pads. It is retained as minute bodies of water filling part of the pore space between particles. This is a figure showing hygroscopic water, capillary water, and gravitational water. Fill capacity. In many soils, after a rain or irrigation, the soil immediately starts draining to the deeper depths. After 1 or 2 days, the water content in the soil will reach with time, for many soils, a nearly constant value for a particular depth. This somewhat arbitrary value of water content expressed as a percent is called the fill capacity. Usually, fill capacity is determined in the laboratory by the retention curve method. In this method, the value of the fill capacity moisture is represented by the balanced moisture with tension of 6 to 33 kilopascal, depending on the texture, structure, and content of organic matter in the soil. At fill capacity, the water and air contents of the soil are considered to be ideal for crop growth. Wilting point. The water stored in the soil is taken up by the plant roots or evaporated from the topsoil into the atmosphere. If no additional water is supplied to the soil, it gradually dries out. The drier the soil becomes, the more tightly the remaining water is retained, and the more difficult it is for the plant roots to extract it. At a certain stage, the uptake of water is not sufficient to meet the plant's needs. The plant loses freshness and wilts. The leaves change color from green to yellow. Finally, the plant dies. The soil water content at the stage where the plant dies is called permanent wilting point or wilting point. Available moisture. The difference in moisture content of the soil between fill capacity and permanent wilting is termed the available moisture. Available moisture can be expressed as percentage moisture, as percentage, or as depth. The available water content depends greatly on the soil texture and structure. The fill capacity, permanent wilting point, and available water content are called the soil moisture characteristics. This figure shows soil-water plant relationship. Students, please note down the assignment for this lecture 5. Now I will show you a video. Thank you, students.
Capillary action is the movement of liquid along a surface of a solid caused by the attraction of molecules of the liquid to the molecules of the solid. Let's simplify. Plants use capillary action to bring water up the roots and stems to the rest of the plant. The molecules of the water, the liquid, are attracted to the molecules of the inside of the stem, the solid. This attraction is used to help force the water up from the ground and disperse it throughout the plant. There are three forces involved with the process of capillary action. Let's discuss them. Adhesion is the process of attaching one thing to another. For plants, adhesion allows for the water to stick to the organic tissues of plants. Cohesion keeps molecules of the same substance together. For plants, cohesion keeps the water molecules together. Surface tension is the effect of intermolecular attraction that causes liquids to form a top or outer layer that behaves like a thin film of sorts. Surface tension is responsible for the shape of water drops and for holding the structures together as plants soak up the water. Although you may use water to help get sticky substances, such as syrup, off your hands, water itself is actually sticky. Water molecules not only stick to each other, but water also sticks to grass, cloth, organic tissues, soil, and paper towels. Plants take advantage of water's stickiness to organic tissues and soil. As mentioned above, capillary action is the movement of the water through the plant. This movement occurs when the adhesion is stronger than the cohesion. Water molecules are naturally attracted to each other. This attraction comes from the temporary hydrogen bonds that they form. So basically, a water molecule has to choose to stay with the other water molecules or go stick itself to the organic tissue of the plant. When the molecule is more attracted to the plant, it is pulled toward the organic tissue. Although the attraction is stronger to the tissue, the water molecule still wants to bring its buddies. Therefore, the first water molecule still attaches itself to the plant tissue, and it also brings along water molecule number 2. Plants need water to grow.
Now we're going to demonstrate field capacity. Now I mentioned to you before that field capacity is when the soil has all the water it can hold under the pull of gravity. Okay, so now we're going to add some water to this sponge, a little bit at a time here. So now we're irrigating. This is what you would do when you're irrigating, only you would want to calculate how much water you need to apply, and you need to understand how much water your irrigation system puts on, etc. Okay? Now, you see that there is no water coming through the sponge. There's no water coming through the soil profile. This sponge is now at field capacity. Now, if I add, just let's say, one more drop of water, water comes through the soil profile and drips down and out the bottom. And if that's past my root zone, the plant physically cannot get that water. And it's going to go into the groundwater, taking whatever nutrients or chemicals, herbicides, pesticides, other things, whatever is in that soil, take it with it into the groundwater and back into the river system. Here in the upper basin of the Colorado River, we are very concerned about salinity and saline return flows into the Colorado River system. because of the amount of money and damage that it causes downstream in the Colorado River and on into Mexico. The first definition I'm going to talk about a little bit is called wilting point. And that's where, when the soil's dried out so much that the plant cannot extract enough water to keep its self-turgid, the leaves actively growing, instead they fold down because they cannot keep turgid and upright, then we call that wilting point. It's just too hard for the plant to pull the water out. The other concept that I want us to learn is called field capacity. Each soil, depending on the soil texture and structure, and the amount of organic matter is very important also, will hold a certain amount of water under the pull of gravity. Once you add any more water, that water continues down through the profile and eventually will enter the groundwater, and the return flows into river systems. At wilting point, there is still moisture in the soil, but the plant cannot get it away from those soil particles, cannot get it inside its root cells and into the plant. No matter how hard it tries, it can't get it in. But it's still a little bit damp. That's wilting point.